Right, in this video, we're going to talk about 3.5 Objective 6, where we verify statements involving trigonometric expressions. Let's go ahead and get started. So how would we verify that the derivative of cotangent is negative cosecant squared? We'd have to use the quotient rule, and we'd have to take the derivative of cosine over sine. And so that's going to be b. Here, cosine over sine, the derivative of cosine is going to be negative sine. Leave the denominator sine alone, minus the derivative of sine is cosine. Leave the numerator of cosine alone. Denominator of sine gets squared, and then it's negative sine squared plus cosine squared. So cosine squared, negative sine squared minus cosine squared is a negative sine squared plus cosine squared is a -1. So that's a -1 over sine squared. They skipped some algebra steps there. Then that sine squared comes up as a cosecant squared and makes it a negative cosecant squared. So the correct form here is B, not A. All right. How would we do derivative of cosecant? So cosecant is 1 over sine, and then so that's going to be 0 times sine, that's A, minus 1 times cosine over sine squared. So that's a negative cosine over sine squared. Cosine over sine is cotangent. 1 over cosine is cosecant. Cosecant and cotangent with a negative in front of it. So that's A. A differential equation is an equation involving an unknown function and its derivative. Consider the differential equation. Y double prime of t minus y of t is equal to 0. And we'll do more of this type of thing in differential equations, but show that a particular function satisfies the differential equation. So if y is equal to a sine of t, y prime is a cosine of t, y double prime equals negative a sine of t, then the second derivative plus the original is equal to 0. So yes, it's true because the second derivative is equal to the opposite of the original function. Is y equals b cosine of t an answer? Let's see. Y prime is negative b sine of t. Y double prime is equal to negative b cosine of t. So yes, the second derivative and the original are opposites. B, yes, that would be a solution. Now let's look and see if the sum of these two things together, this is a general principle in differential equations, that if these two things are particular solution or are part of a bigger solution, then because these have generic constants a and b in front of them, that I could put them together, because in the first case, this constant in front of the cosine part here, this b was just a 0. And this part here, this a was just 0. Just put them together because these are generic constants, and it's called the superposition principle. But you just find the little individual pieces and you put them together to make a big general solution with the superposition principle. So we're going to have the second derivative, if we have y equals a sine plus b cosine y prime, it's a cosine minus b sine y double prime equals, and it's these things here, negative a sine minus b cosine. So that's c, right? Part C. No, A. Negative, negative, right? And so yes, that's an answer as well when I add them together. There we go. All right, and then I think I've already done this in a previous video, but let's talk about how I can use the double angle identity here with the product rule to come up with a derivative for sine 2x. So the derivative of sine 2x, knowing that sine 2x is 2 sine x cosine x. So the 2 stays out front. Derivative of the first part, leaving the second part alone, plus derivative of the second part, leaving the first part alone, is going to be 2 times cosine squared minus sine squared. That's what they want here. And then using the double angle identity for cosine, go backwards and say that this is 2 cosine of 2x. We also could have used the chain rule with this to get that 2 cosine of 2x to say that the derivative of sine is cosine, leave the argument alone, times the derivative of 2x is 2, and we would have also ended up with 2 cosine of 2x. All right, that's it for this video. We'll come back next time and talk about 3.5 Objective 7, where we solve applications involving derivatives of trigonometric equations. See you for the next video.